Hey everyone, welcome to our last section of the year, 12.8. Pause to shed a tear. Okay, so what am I going over in 12.8? I'm going over ratios. Alright, so we talked about ratios and scale factors of sides. We talked about ratios and scale factors of surface areas. Now I'm talking to you about volumes. Okay, so sides are first dimension, so that's why it says ratio of the sides is A to B. Surface area or areas are second dimension, so that's why it says ratio is A squared to B squared. And then volumes is third dimension. All the units are written to the third power, and that is why the ratio of the volumes is A to the third to B to the third. So that's if they're all similar. If things are exactly the same, they're congruent solids. In these two examples, I'm going to try and prove whether they're similar or congruent or neither. And if they're similar, state the scale factor. If they're congruent, the scale factor is 1 to 1. If they're neither, they don't have a scale factor. So let's just check. You just have to do, does 4 over 6 equal 8 over 12. I like to work left to right using the similar sides or measurements. So we just need to evaluate that. They both equal 2 over 3. So that's good. They are similar. All right. And so you say 2 over 3 is your scale factor, and I'm just going to abbreviate that as SF, all right? This next one, we have several different sides. They all need to have the same ratio. So I'm going to go 2.5, and then I'm going to look at this 1.5 because they're both, looks like side lengths. So, or you know what I mean by on the side. Does that equal, now I'll go like 3 over 1.7 because they're both on the bottom. And then I'll do like 6.2 over 3.4. So what you want to do is type those in individually. And you'll see that this doesn't equal that and that doesn't equal that. None of them, they in fact all make different ones, different numbers. So therefore, it's neither. All right, let's move on to the next one. So here's an example of what I'm going to be talking about. These two cubes at the right are similar. Their scale factor is 3 to 2. So that means the ratio of their surface areas is 9 to 4, and the ratio of their volumes is 27 to 8. Now, how do I know they're 9 to 4? 9 to 4 is the same thing as 3 squared to 4 squared. And it's just what I talked about up above with these little notes right here. Square it, cube it. All right, so if you cube 3 and if you cube 2, oh, I just realized I wrote 4 up above. Let me fix that. I was thinking of 2 squared, and 2 squared is 4. There we go. So yeah, 3 cubed to 2 cubed, 3 squared to 2 squared. That's what's going on right there. So two similar cones have a radii of 10 millimeters and 15 millimeters. What's the ratio of the surface area of the small cone to the large cone, and what's the volume ratio? So the first thing I'm going to do is do the ratio of the surface areas. Okay, so you're going to have to square it. So I just need to type in 10 over 15 squared, and that's going to give me a fraction of 4 over 9. I know my 4s don't look great, but that's a 4 on top and a 9 on bottom. Okay, so what we just figured out was our scale factor of our areas or surface areas, our ratio of it. Okay, let's do what's it asking. It says the volume ratio. Okay, so let's do that next. So I'm going to type in 10 over 15. I go back to the original, and then I'm going to cube it. Okay? That's going to get me 8 over 27. And that's my ratio or my scale factor, or whatever you want to think of my volumes. To me, the terms of ratio and scale factor are interchangeable. So sometimes I'll write scale factor, sometimes I might write ratio. Like I said, they're basically the same thing. So onto the back, two similar prisms have surface areas of 98 square centimeters and 18 square centimeters. What's the height of the large prism and the height of the small prism? Then what's the volume ratio? So I'm asking for the heights. So you have 98 over 18, and though that's already squared, so how do you undo a square? You square root it. So the square root of 98 over 18 is 7 over 3. So what we just figured out is that 7 is the height of the large, and 3 is the height of the small prism. So with that, now I found my scale factor or my ratio of my sides. So what I'm going to do next is I'm just going to write 7 over 3, and then I'm going to cube it for that volume ratio. That's going to give me 343 over 27, okay? And that's the volume ratio right there. Now, this one, two similar cylinders have volumes of that number and that number. What is the scale factor of the smaller cylinder to the larger cylinder? So, and then what's the surface area ratio? The first thing you're going to want to do to find this scale factor is you're going to want to cube root this time. We're trying to undo a cube. So I'm going to do the cube root of 678.6 over 471.2. Looks like that's going to equal about 1.129. And if you want to keep it as a fraction, just throw it over 1. Yeah, either way, that's the scale factor. Okay, so this is the scale factor of the sides. What I'm going to do next with that is, because it's asking for the surface area ratio, I'll keep that as a fraction. I'll do the 1.129 over 1, and I'll square it. And that's going to give me approximately 1.275, again, over 1. And that's my ratio of my areas. And that's it for that one. I got one more example. Here are the containers at the right. They're both similar. Find the height of the smaller container. So what you want to do is do a ratio of your volumes. So I'm going to work from left to right. So I'm going to do the cube root to undo the cube, because I'm going down to the height. That's the first dimension. So I'm going to go 270 over 640. And the cube root of that is 3 over 4. So since that is my scale factor or my ratio, whatever you want to say, I'm going to take that and then I'm going to create a proportion. 3 over 4 equals, we didn't know the height of the smaller one, but we knew the height is 10 over the larger one. So I'm going to say x over 10. Just cross multiply 3 times 10 and then divide. 30 equals 4x. And divide by 4, and you get that x is going to equal 7.5. And my unit on that was inches. Alright. And in my last video, I just went over surface area of a sphere. So real quickly, I just wanted to talk about the volume of a sphere. So volume of a sphere is 4/3 pi r cubed. So if I'm asking you to find the volume of a hemisphere, you need to cut that in half. So you could think about it like this. What is half of 4/3? That's kind of a weird question to ask. Cut that top number in half. What's half of 4? 2. So 2/3 pi times 6 cubed now. All right? Type that in. Your volume's approximately 452.389 cubic meters. Okay? Again, I wrote 2/3 instead of 4/3 because it was a hemisphere. You could have used 4/3 pi times 6 cubed and then just divided by 2 at the end. Either way. But I'm going to do it like that to hopefully strengthen your skills with fractions a little bit if you're confused by them. Now, this one says a sphere with a great circle is a circumference of 18 pi. Well, what is the circumference formula? 2 pi r. So if it equals 18 pi, I'm going to divide both sides by 2 pi. And my pi's cancel out, and 18 divided by 2 is 9. So I have a radius of 9 centimeters. Okay? Now that I had that information, I just say, hey, the volume is 4/3 pi times 9 cubed. And I type that into my calculator. My volume's about 3,053.63 cubic centimeters. And that's it for the notes. Thanks for watching, everybody. I will be posting videos of the semester exam review, but that's it for all the textbook sections. Had a good year. Thanks for watching, and like and subscribe. I don't really care, but yeah, goodbye, everyone. Thanks.